Dear students, we know that there are two types of growth models. First is exponential growth model and second is logistic growth model. In our previous lecture, we have talked about the exponential growth model, and in today's video, we will talk about the logistic growth model. Here you can see the graph for logistic growth model. Here in the same graph, there is a curve for exponential growth model also. This curve A is for exponential growth model. As you can see, the shape of the curve is J shaped and it is showing the continuous increase in the population density with respect to time. Now in the logistic growth model, here the B curve B is for logistic growth model. Here you can see that initially there will be increase, and this increase is not the infinite increase, like there is a limit to this increase up to this level. Here you can see a line, up to this level the population density is increasing, but as it reaches this level, what will happen? The population density will become stable with respect to time. So what is this level known as? This level is limiting the population density. This level is known as K and it is known as carrying capacity. So what is carrying capacity? Carrying capacity is the resources available in any habitat that are required to support the maximum number of individuals there. And beyond this level, the limiting factor, which is known as carrying capacity, the habitat cannot support more individuals. So you can say this is a limiting factor, and if we have to find out the equation for logistic growth model, we can derive the same from the equation for the exponential growth model. Up to this, it is an equation for exponential growth model, change in population density with respect to time. Then here small b is birth rate, small d is death rate, and when we use this value, we can replace it with r. R is the intrinsic rate of natural increase. So up to this level, the equation is for exponential growth model, but here we are not including any limiting factor, because in exponential growth model there is no limit to the growth of the population. But here if we change this into logistic growth model, then we will add the limiting factor, that is K. K is the carrying capacity beyond which population density cannot increase. So we have included this factor in this equation to convert exponential growth equation into the logistic growth equation. So how we will write it? dn upon dt, r, that is intrinsic rate of natural increase, into the population density, then we will include k minus n upon n. This is the limiting factor. So this is the equation for logistic growth model. Thank you.